In this lesson, you will continue to learn about the properties of exponents, focusing on the power to a power rule for exponents. Let's take a look at what this means. In the power to power rule, you have a base inside parentheses, and it has an exponent. But there is also an exponent outside parentheses, and what you do with these two exponents is you simply multiply them together, as shown on the right. So for example, if we replace these two exponents with actual numbers, possibly giving a an exponent of 2, so a squared, then we have an exponent outside parentheses of 3. What we would need to do is distribute that 3, and since distribute means multiply, we will multiply the 2 and the 3, giving us a to the 6th power. So power to power tells you if you have a power next to a power like that, you multiply them together. Let's take a look at some additional examples. Okay, in this particular example, notice at the top it says pow, pow, multiply now. That's a little rhyme to help you remember what you do when you have an exponent next to an exponent. So here we're going to multiply 2 times 3, which gives us 2 to the 6th power. And then of course, because the base is an actual number, we would then actually multiply it out. So 2 times 2 times 2 times 2 times 2 times 2. So if you multiply that out, it would be 4 times 4 times 4, which would then be 16 times 4, which would then be 64 for the final answer. Okay, if you look at this chart, these are actually mixed up in random order. So we want to know which of these would we want to add exponents first, and which of these would we actually want to multiply. Now remember, to multiply exponents, you want that idea of the pow, pow, multiply now. You want an exponent next to an exponent. So let's look at this first problem. In this problem here, do we have an exponent next to an exponent? Yes, we do. So this indicates we're going to do the pow, pow, multiply now. It will also be multiplied by the 2. So every exponent inside parentheses will get multiplied by the one that's outside. So this particular problem needs to move over to the multiply column. So it moves over here. So let's move this one out of the way. Okay, so what about this one? This 2, the x inside has its exponents, it's just invisible. But it will get the pow, pow, multiply now, as well as the 3, which we will get into in a second. That will also get the 3. So this is another example of multiplying first. So you're looking for that exponent that's outside parentheses as your clue that you're going to be multiplying. What about this one? In this one, notice there are no exponents outside parentheses. So this would be an example of the product of powers where you actually add the exponents to combine the variables together. So this example would stay under the adding column. This next one I'm moving up. Notice there are exponents outside parentheses. This indicates the pow, pow, multiply now rule. So this one is also an example of multiplying the exponents first. So we're going to move that over to this column. Let's move 3x cubed over here. So this one is a pow, pow, multiply now, because we have the exponent outside parentheses. Okay, what about this one? There are no parentheses, so obviously we're not going to be doing any pow, pow, multiply now, so that will stay in the adding column, because we'll just simply add the exponents of the common variables. And then this last one has parentheses, but notice again there are no exponents outside the parentheses, so we will not be doing the pow, pow, multiply now. So this is simply using addition of exponents to combine variables together. So if you look at what's in common between the expressions in each column, especially in the second one, you'll notice every one has an exponent outside parentheses. And that's your clue. You're going to be multiplying the exponents together. In the first column, because there are no exponents outside parentheses, you will not be doing any multiplying. So the only thing you will do with the exponents is add. So let's take a look at some more examples of the power to power rule. So here's one where you just simply pow multiply now, which gives you a to the 8th. Now, this is where it gets confusing, because inside the parentheses in this example, we do not just have one base, we have two. The 3 is a base, and the x is a base, and each base has its own exponent. So I'm going to put a 1 with each of those because they don't currently have an exponent. So the pow multiply now will apply to each exponent inside the parentheses. So it comes out 3 to the 3rd power when you multiply the 1 and the 3. And then the x will also have an exponent of 3. To then finish this problem, because the base is a number, you need to calculate 3 to the 3rd power. 3 times 3 times 3, which equals 27. So my final answer will be 27x cubed. Let's take a look at another example. In this problem, there are 3 bases inside parentheses. And we have our exponent outside of the parentheses, which tells us we're going to do the pow multiply now. Now, the -4 needs an exponent, the x has an exponent, and the y needs an exponent. So each base, again, has its own exponent. So we're going to multiply the 2 by each exponent inside. So what it will look like is the -4 will now have an exponent of 2. The x will have an exponent of 6 because 3 times 2 is 6. And then the y will have an exponent of 2. And then the last thing we need to do is simplify the -4 squared, which means -4 times -4, or positive 16. So our final answer should be 16 x to the 6th y squared. Okay, let's move on. This is the last one. Okay, in this one, we're going to have to do the pow multiply now for 2 different sets of parentheses. Now, what's confusing in this one is this negative sign. This negative sign, as you've learned before, when it's in front of a variable, it means -1. So it's actually its own base. So it needs its own exponent. So we've got 3 bases inside this first set of parentheses. The -1 needs its own exponent. So the 4 on the outside of the parentheses will be multiplied or distributed to all 3 exponents. So it will look like this. The -1, once the 1 and 4 are multiplied, will have an exponent of 4. The m will have an exponent of 12 once the 3 and 4 are multiplied. And the n, an exponent of 16. So this is our first set of parentheses. In our second set of parentheses, we also have 3 bases. They do not have exponents, at least as we see it, so we need to put in those exponents. And then the exponent outside, we will do the pow multiply now. So each exponent will get multiplied by 3, leaving us with 2 to the 3rd power, m cubed, n cubed. Now, we just did the power to power rule. Now we're going to backtrack, and now we're going to apply the product of powers rule. So now we need to simplify the bases that are numbers. So -1 to the 4th power, which is -1 times -1 times -1 times -1 equals a positive, a positive 1. So I don't even need to put the 1. I could actually just get rid of it if I want to, because you don't need a 1 in front of a variable. So let me drop down m to the 12th and n to the 16th. Now, over here we have 2 cubed, which is 8. And then we'll drop down 8, or m cubed, n cubed. Now your number should always go in the front of your answer. So we'll put the 8 in front. Now reminding you, for the product of powers, when you're combining 2 variables into one, that's when you're adding. So you're going to add those exponents, giving you m to the 15th. Then we also need to combine the n's together by adding its exponents, giving you n to the 19th. So your final answer is 8 m to the 15th, n to the 19th. So we combined both of the rules, product of powers and power to power rule, to complete this particular problem. And that ends this lesson.